Leonid, Pablo over there, and Martin. 3 musketeers from Oracle for the day. We're going to do a bit of a workshop on architecture design. Before we get into this, we do work for a large publicly traded, as of yesterday, second largest technology company in the world, I guess. So our legal mixer says that the opinions we're going to be expressing here are our own, and by no means represent the company whose logo the slides and my t-shirt bears. It is what it is. What we're going to do today is we're going to talk a bit about the workshop. We're going to give you a problem statement. Then we're going to break into, we'll figure out maybe 3 teams based on the number of people that made it, and do some design exercises. And then at the end we'll do a review. There will be a winner. You win nothing but pride and admiration of your peers. There are no prizes. Kata. What is kata? Kata is the Japanese word. Here's a definition from Source of All Truths in the World, the Wikipedia. It's the repetition of a particular martial arts move in order to get better at it. And both Martin, myself, and I have been designing software systems for many, many years, and what we learned that you learn through repetitions. And a lot of times, some of the things we've used in our previous systems as designs evolved to other systems, or some of the questions we forgot to ask a customer or a product manager, we learn to ask next time around, right? So, we're gonna train today. Quite often software systems are designed like that. I'm sure most of you have seen this cartoon. I saw it for the first time in the late 90s, right? Customer wants this. We kind of end up building something like this. We kind of document it like this. That never happens, right? By the time it goes to production, it's this. We build it like that. And customer really wanted that. And quite often when we're dealing now with non-technical customers, it's very difficult to figure out what is that they wanted to. Rules. Very simple. Part 1, design. We're going to design in, I think, 3 teams or so. I guess 2 teams of 4 and 1 team of 3. We'll let you guys figure out how to split. I strongly encourage you to try to be in a team with people you don't normally work with, because that's how it happens in real life. No internet, no phone allowed. You can make assumptions as you go about how certain things work, but if you do, you have to be explicit about them when you present the designs, right? You can ask, we'll play the role of the stakeholders. You can ask us questions at any point of time. And we have 3 whiteboards, which is good, 3 large whiteboards. So draw your designs as you go, because you won't have time to do that when you end up presenting them. In part 2, we're going to do a review. And in the review, be prepared to be asked questions by everybody, and everybody in the group is encouraged to ask questions. Again, we're not going to challenge each other on assumptions, as long as they're reasonable assumptions, not like outrageous assumptions that we thought we'd get to spend as much as we want on hardware. That's not a valid assumption. Right? And we as stakeholders will ask questions as well. Now, in terms of the language, any language works for us. Несмотря на то, что я когда-то долго рос в Питере, я довольно давно живу в Северной Америке, поэтому с профессиональным русским мне значительно сложнее, но если кому-то проще делать... What's so funny? You get all this. Мартин прекрасно понимает... Мартин прекрасно понимает русский, но он в этом не признается. Пабло великолепно добавит немножко...
Ничего не понимаю.
Brazilian Portuguese. Вот, поэтому если проще задавать вопросы на русском или делать презентацию на русском, нет проблем, но language barrier как, as a concept actually is a big challenge today. We work in a highly distributed teams. My team today is spread across 4 different locations, speaks, well, a lot of them actually speak Russian, English, French, Polish. Our customers are all over the world, so language is a barrier. I actually spent 5 or 6 hours with our sales team in France just to realize that a term that we're using, interface, was really referring to an integration interface, not to the user interface. And the conversation went completely apart because of that. So language is a key thing. Stakeholders, so we're going to play 3 roles. Martin gets to do what our sales team gets to do to us. He'll be the sales guy. I will be the product manager, and Pablo is a consulting architect. Pablo is actually a real-life architect. Cherish him. We took him out of the exhibit case and brought him out with us. He's an architect on one of our products. Actually, one of the products is EPAM using to hire. We all work on Oracle Taleo suite of products. So feel free to, and he'll roam the room, all of us will roam the room. Feel free to ask him questions as you go if you need a architecture consultation. And I think with that, our sales guys just called.
All right. So, end of the year coming up. My car is kind of old. I need to buy myself a new gift. So I've gone out to one of our favorite customers and pitched him on an idea. So the customer has a lot of cars, and some of those cars have some devices installed on them, and basically the problem is they never know where the cars are, and they'd like to be able to track them. So myself and Leonid were there, and I obviously said, yes, we can build this for you, not a problem, we'll turn it around in a month or so. It's going to be quite inexpensive, working flawlessly, and we talked about the design. I agreed to everything they asked for. He was going like this throughout the meeting. So now we have a product we have to build.
Yeah, no, guys, I was there to gather some requirements. I don't know what Martin has heard, but yeah, we certainly sold something, so. I'll try to explain what I heard from the customer, but we may have to go back and forth, and if the requirements are vague, ask a question. Martin and I will go do a drinking session with the customer, and we're happy to do that anytime, and try to figure out what they want. But in reality, what I heard is they have those trucks throughout the world. And on the trucks, they have this thing that can grab a GPS signal and can grab a bunch of Wi-Fi signals, that would be an interesting thing. Wi-Fi signals. Right there. Hey, I'm a single guy. Wi-Fi signals, as well as the signal strength. So basically it gets a MAC address of the access point, the name of the access point, the timestamp, and the GPS signal. And they already have this hardware device, and what comes out of it is just a stream of records. As you drive around, that stream of records comes out. Now what we think we need to build is something that will take that data, eventually put it in our cloud service, and we'll post-processor will do what we need with it. I don't know what yet. We haven't figured that out. That's why you developers come in. We're just empty suits here. And then we need to ultimately deliver an SDK, which is not in scope for this exercise. There's this other team we've outsourced to in India. They'll build the SDK. Don't worry about them. Don't worry about them. They're this awesome. We'll eventually give them the spec, but for now they're already working on something. So it's a mobile SDK that will get embedded into a device like this. A device will see what Wi-Fi access points it sees around itself. What's the signal strengths? It will send this data to the server, and we really need to return some coordinates back, right? And maybe some accuracy, because I don't know how accurate we can be. We've got to think about that.
As accurate as humanly possible.
Yeah, that's right. Is that what it says in the contract?
That's what I saw.
Shit. All right. Well, we'll figure that out. I think I'll have to go back and negotiate with the customer. We'll give them something back in return. Well, maybe discount another 5%. Sorry, your commission.
Coming up for my commission, we're not doing that.
You guys are going to be laughing, but those are the conversations we sometimes have at work. Although with the other side, it's nice to be on the other side, right?
Oh, yeah.
So really, that's the story. You can clarify the requirements. We'll do a group session so everybody can ask questions. And then deliverables, what we want to see in the review. High-level architecture, a component, system diagram, right? Component diagram for all key components. Remember, we have really two key areas here, the car and whatever we run in this magical cloud of ours. We're a software incorporated cloud, right? We have our own cloud services. Think about things like deployment, redundancy, reliability, resilience, cost, throughput, all the usual considerations that we never think about when we design systems. And then, if you have time, and go in this order, some key entity diagrams, right? If you want to do UML, great. If you don't, boxes are fine. Just what are the key entities, data entities that we're storing in the system? How are we organizing the data? What are we doing with the data? All right? So, before we split into the teams, let's do a quick requirement clarification session. Any questions or requirements in any language, including Portuguese, if anybody can get it. That's a special prize.
I'll give you the answer if you have something.
Oh, nice. So, any questions or requirements?
Why do we need Wi-Fi signal? I mean, if the car already has the GPS tracker, why do we need Wi-Fi?
Because ultimately what he sold is not what the customer wants. The customer wants an SDK for a device that may not have a GPS. Otherwise we wouldn't be gathering. So we try to do geolocation based on Wi-Fi signals. While the cars that gather the data have the GPS on them, so we can correlate the signals with where they are located, right? The devices that ultimately will be using the data, the SDK we're building will just use the Wi-Fi. And by the way, just so we don't stretch the truth that far, this is how this and Android really works. You can turn the GPS off. It will still reasonably well today geolocate you in any major metropolitan area to like, actually we won't talk about how much you'll figure out what's the reasonable accuracy, I think. Does that make sense?
Yeah, but that's Android. They have, I guess that Google has a database of all the Wi-Fi access points. We don't have that.
Well, that's what we're building it. He sold that.
Okay.
Right? Cars drive around, gather this data. Right? So the device on the car basically is able to output as the cars drive around the cities and gather the data. So the cars will roam the city like Google cars would do and gather the data. It's a good point. And what they gather again, the hardware is already taken care of, basically spits up events. Here's my position in GPS, Wi-Fi access point, maybe MAC address, and here's what what the signal strength is at any given point, right? So that's the gathering bit, and then the querying bit goes into the SDK. Does that make sense?
Yeah, a little, but makes.
Okay, well, I think there was another question.
Customer will use just the mobile phone without, will he use a computer
For the location?
for check location?
Yeah, well, now the SDK, the guys in India building are for the phone right now, but God knows what they're going to ask for later. Martin, have you promised anything else to them?
Head implants down the road.
Head implants?
Yeah.
Oh,
Brain implants
okay.
in the future.
In the future. That's future roadmap. So the querying device will be the device that low power, right, and can just communicate with the server with the data. Basically, and I see some access points around me. Here's the signal strengths. Tell me where I am. Any other questions?
Do you have any limits for the tracks? How many we can use?
No. Assume tracks are plentiful. Assume, by the way, we're starting from zero data, so it will take a while to build up the data in the system, right? As the tracks and
We can use a limited number of tracks?
you can use unlimited number of tracks. The guys
They
you
will
sold
do.
us, so they're like in a package delivery business, so they drive throughout all the cities where they're present, so eventually we'll gather enough data. But early on, probably, it's a good question, early on the database may be sparse. Right, we may not have the data on every location, in every place where we may get
But the
queries.
company is expanding rapidly and they're doing good business, so we don't know what the future brings.
Let me guess, you want to sell more stuff to them. Those salespeople.
We built something that we need to upgrade later on. No.
Oh yeah, that's important. I heard from the customer. Trucks are very important to them, right? They make money by having those trucks on the road. So upgrading the stuff that we're going to put on the truck means downtime, and they're kind of worried about that. So we need to figure out how to be really efficient about not taking their trucks off the street, because they stop making the money if they're off the street if we need to do maintenance or upgrade or something like that.
So, and all this data should be like monitored on the big screen on a data center or something.
And I think they've asked for it, but I do know like customers like pretty pictures. They always like pretty pictures.
Exactly. If you build it, I can sell it.
It's not real time. Not real time.
No, there's no real-time requirements, and yeah, we don't know how the data needs to be gathered. But that's up to you guys to figure out what's the right thing.
And should it work for some specific location, or do you have a specified country or where?
Well, they're in a few countries right now, right? But you said they're expanding.
They're international, they're expanding, so we should probably aim at pleasing them in any given location they choose to go to. So anywhere.
Yeah, we'll have to.
Do we have any requirements on availability for this service?
Availability. Oh, Martin, what SLAs did we put in
We
the
didn't
contract?
sign any ACA,
Whew.
but I did promise 24/7 and quite a few nines.
How many?
Depends.
You know, each 9
Well,
was a
you
big
know,
difference.
it really depended on the talk. One person I promised 3, the other one I promised
And what's in the contract?
3.
So 999. Oh, that's it. God. And by the way, a little exercise for those of you who don't know how to calculate. Figure out how many hours of downtime 3 nines means. That's actually very lax SLA.
Yeah, well,
But thank you for that. At least you brought
I
something.
know. You kind of told me something about those 9s some other time, and I figured
Yeah, it's like 4
Three's
hours,
a nice-
40 hours.
3 is a nice
40
number.
days.
3 is a nice number.
You could have done 2. Like 99% uptime means we can be down for 36 and a half days a year. That's awesome. Oh no, 3.5. See calculations. All right, what else? Actually, Martin and I have to go to a sales call, so other questions?
Some more stuff we haven't built yet.
That would never happen. So guys, figure out what the teams are. You have whiteboards. We'll raise the screen. We're going to design for about 45 minutes.
I have one more question. May I?
Can we be late for that customer meeting? Fine.
5 more minutes.
Again, just on a high level, we need to build a system where someone sits in the office and can see where all the trucks are located.
Absolutely not.
Okay, so I'm wrong. I don't understand.
We're building a system that allows a device like this ultimately to send a query to the server over the network, say, hey, this is the Wi-Fi networks I see around me. This is the signal strength I see around me. Tell me where I am.
Using the knowledge base that was created by the trucks that are going
Yeah,
out.
the trucks gather the data, they figure out, they map the access points, the signal strengths, etc. And eventually the SDK that the guys in India have already almost built probably by now, they're very productive. I wasn't in the meeting with them, they said yes, it's ready.
Everything's done. We're ready.
Ultimately this device will say, hey, I see an EPAM network, and I see that network, and this network, and here's the signal strength I see, tell me where I am.
Okay, why don't just buy a GPS and put it into the device?
Expensive.
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 More expensive than building a system, right?
Well, but we sold the system to the customer. Seriously, man. We specialize in selling stuff to people. That's why he needs an upgrade of his Mercedes.
business. We're in the SDK building.
Exactly.
business.
He needs his DB9, right? Is that what you're getting out
That's
of
what I'm
this
getting
deal?
at, yeah.
Good for you.
No question. How many devices are you going to support?
Devices in terms of the query?
Yes.
Oh, you know what? I'm going to have to go back to the customer and clarify that. We'll get back to you in 5 minutes. We'll have a call. We'll do some requirement gathering. I forgot to ask. Seriously, I forgot to ask. So stay tuned. We'll provide a further update. New requirements may emerge down the road because that never happens in real life. All right. 3 teams, 1, 2, 3 big whiteboards. I guess we won't need the fourth one. We're going to design for 45 minutes starting now, so it's 10:30. We'll finish the design at 11:15 and we'll switch into the presentation mode. Again, the deliverables are high-level architecture, component diagram, some entity stuff, and the description of how the system works. Be prepared for critique. Thanks, guys. We talked about 2 things. We asked the question that somebody asked about how many devices. So we're going to support 500 queries a minute. That's the goal. The customer also told me that they're worried about the mobile battery life. So the protocol has to be pretty efficient so we don't burn the battery. And then we were very lucky. We hired this nuclear scientist PhD from Arzamas who is working on the algorithm that we can use to figure out how to turn the raw data into the location. So we don't need to worry about that. He's in his nuclear bunker designing that right now. We're good to go. We're going to do 3 presentations, 15 minutes each. Each team gets to present their design. The rest of the teams get to question it. We did bring finally our architect. He was traveling. He's off his ivory tower. He gets to ask really hard questions because as a chief engineer for the company, he gets to sign off on this before we actually start building this. It's a lot of money. Although, by the way, I heard from the guys from India, they're on their 5th version of the SDK already. They're chugging along with this, thank God. So hopefully what they've built can talk to our server, but we'll deal with that later. So pick a language that you prefer. If it's not English, I'll do my best to translate for Pablo, and you know, I do a lot of other things professionally. Translators, I guess, is going to be one of them. And then at the end, we're going to do a wrap-up and a vote. The way the voting is going to work, you get to vote for one of the two other teams as a team member. Everybody gets one vote for the design that you like the most, that you think is the most comprehensive, and you think that satisfies the requirements closest, at least based on the requirements we all heard today. With that, we need a volunteer, and there are two ways to do the volunteering thing. We can do what my sergeant in the army used to do. I can name names and point fingers. Or one of the teams can volunteer to go first. So, who wants to go first? All right, we have a volunteering team. The floor is yours, sir.
Okay.
Oh, the sales guy!
So, I will start with the high-level description of the system. Then I will go to the components that we have and describe the data entities that we will use.
Okay.
First of all, on the high level, we plan to build two services, one for the input data and one for the query API. We plan to use a single server which will process this data and MongoDB to store it. So how the data will flow. The gathering trucks will travel around the city for an entire day. Then at the end of the day, when they arrive to the parking lot, they connect to our FTP server using Wi-Fi. They upload the files that they collected to the FTP, and we have a scheduler which schedules an import job, which processes the file and puts the data to the Mongo database. So this happens independently of the query service. Then when a query client comes, it makes a HTTP request to the query service, which using this sophisticated algorithm gets the data from Mongo and returns a meaningful response to the client using REST and JSON to transfer the data. We also have a cleanup job, which is also scheduled by the famous scheduler to remove the redundant and old data from the database. That's the high level. A bit more about the decisions that we made. FTP and Wi-Fi is because we didn't want to bring 3G to the gathering devices, to the gathering trucks.
Why not?
Because it's expensive.
Okay.
And also because the gathering device may generate tons of data, which may be too much for 3G. So we upload the data once per day. Why Mongo? Mongo is because it will scale on large amounts of data, first of all, and the second reason because we can easily create sharding and partition data depending on the geolocation. So that's why we choose Mongo.
Okay.
Basically, I've said almost everything. Yeah, the data, the data entities, there's, to say, just a single entity which represents the access point. So we have the MAC address of the access point, the coordinates that the gathering device recorded, the strength of the signal, and also the date when the point was recorded. We think of keeping the last, say, 10 recordings for the same access point, so the database does not grow too much. The cleanup job will remove those that are old. Basically, this is it.
All right. Questions?
Why do you need the scheduler to move data to Mongo? Why you don't like directly move?
Well, there are two ways. We could have made a service and the gathering client would upload the file using FTP and then notify the server, hey, there is a new file, please process it. It would be a bit more complex because the client would have to make one more call and have to need to know that there is some service to call. It's just simpler this way.
And why is it important for the client to be simple? Like, why do we care? Do we care?
Yeah, we do.
Why?
It's less job for us. I mean,
Okay.
It's also better because we can schedule how much files can be processed in any amount of time. If the trucks come in the single moment at the parking station at the time 9 o'clock and begin to push to our service big amounts of data, we just can be off of the service. So we decide when we import our data.
Okay.
What is all data in your database? You have a cleanup job and you're going to delete some data from your storage. How do you know that this data is outdated and what?
we record the date when the access point was recorded.
Okay.
And those that are, for example, we record up to 10 records for each access point. And those that are older, we remove them. If I have like 20 records for the same access point with the same MAC address, I think that I can remove those that are old.
So the answer is that you remove all data.
We keep the last 10 entries, the latest 10 entries.
So it's the most relevant.
Okay, thank you. That's
Well, why 10? Because I mean, you get the access point, but then the signal strength might be different. There's a radius, right? I mean, I guess I'm trying to figure out. It does seem like an interesting point, but why 10 versus
100.
Yeah.
Well, I think it will depend on the algorithm, how much precision can we get out of it. So we can increase this number to say 100. But the point is to keep the data like relevant and up to date, because access points may change the signal strength. So.
All right. Any other questions?
How are we going to achieve a goal for 500 requests per minute?
Yeah, I was very quiet. You guys haven't talked about that.
It's all about
It's about services. It's about making a query service and an import service is separate services and being able to scale only the query service. So if we scale the database and also scale the service for queries, we can probably make it.
It even gets more efficient if we scale our databases, if we shard them so they will be independent from other cities and other districts, and it can be like completely independent. So it's completely scalable for real world situation. Okay.
By the way, so 99.9, how many hours can you do downloads a year?
So you know, a couple of seconds from
1% is 3 days. So
0.1 is like 48,600. So it's like 1 day per year. Right?
Yeah, maybe. Like
8.76 hours. And it's important, guys. The reason I ask this question is, we all throw those numbers about SLA, availability, uptime, response times, right? They have to be very, very concrete when you think about it. Like 5 nines is 4 minutes a year. Sorry, 8 minutes a year, right? Of downtime.
Oh.
So that stuff is important not to leave to some abstract that's 3 nines that the guys put it in the contract. 4 hours may mean you change your deployment process sometimes, right? Or you cannot take the system down. So anyhow, I rest my case. Any other questions? We still have some time. All right. Well, thank you very much.
One second.
Oh.
About FTP, device will upload to the FTP this data,
Yes.
or
Yeah, device just stores, as we discussed with the product manager, device stores the data to a file, and when the truck arrives to the parking lot, it connects to wireless network and uploads the file to FTP.
To save battery time.
Yeah. No, it's not about the battery time.
Why?
The battery time is an issue with an SDK running on.
But what device will be gathering the data? Isn't it the same device?
No.
No, it's
It's different.
okay. Maybe our Indian developers should worry about battery life and other.
So speaking of that requirement, how did you guys account for making the SDK as battery efficient as you can? What were the considerations? What have you guys put into the design?
Just to use the G cell to make it more lightweight and consume less resources while processing it. That's the only thing that we did. The rest should be done by Indian colleagues. Probably.
Okay, so we don't believe that there's anything else that you need to do on the server to make it more efficient,
Or can do.
or can we do anything else on the server to make it more efficient?
Maybe cache something, but it do not change how battery life looks.
Or let me rephrase the question. Even how would you go about finding out what else could you do to make it more efficient for the client? Like, let's say you don't know, it's the first time you're designing something with a mobile app. What would you do next to figure out what else can be done?
Probably check what consumes the most energy on a device.
Okay. Radio does.
Sorry?
Radio.
Oh yeah.
Right, this thing has to talk to an antenna, God knows where, through walls, concrete, all that stuff.
Yeah, well, with our application, I guess they would need to use the 3G, which would consume the most memory. So I guess but it's up to SDK or application developers to decide when to connect. If they do not keep the connection live all the time, but connect only when the user requires the application, or maybe query the server once in a minute.
Maybe if the list of available Wi-Fi points change, maybe at that point they will query our service because they have not any meaningful reason to do this if Wi-Fi points do not change their strengths.
Okay. And by the way, SSL or HTTP, like HTTPS, HTTP?
Do we need this to be secure?
What would you recommend?
Oh yeah, sure. If the client does not want anyone else to know where the truck is, where the car is located, it should be HTTPS.
Okay. All right. Thank you very much, guys. Who wants to go next?
Wait. Have we explained the format of how we're going to vote on this?
Yeah, the sales rep was out of the room. Busy selling what we don't have, something else. Yeah, go ahead, guys.
So we have mainly created this process point that describes where is the high on the Earth, it's like latitude and so on. And we have our input data, it's actually some kind of set of the Wi-Fi identifier. We use MAC for this, and we use strengths to find like how far we're from it and so on. So these are entities. We do have actually like two kinds of job. First is to collect data, and second is to actually use it. So in for first case, we do some tracks that have GPS installed on them, and we collect hazard data from them each time they came to some service. So it could be one time per day, or often if they do like this more frequently. We upload this data to a server, just like a raw data with binary protocol to save some traffic and so on. And when we use it, we do send or like some data about Wi-Fi around us and receive point, and we do this in binary protocol too, to save energy and to make this world more efficient. So what do we have in our server? We serve So actually we have two use cases. First one is our usage from let's start from other one, like the student data. So some data came to us, and we have some knowledge base. We put it in there. We don't have any scheduler for this, because we will try to do it without it, like the simplest way that works. We are more agile, and to see if we will need it, we will implement some other kind of thing. And the next one is use. We take this data from binary protocol, make some more, like serialize it to some more domain-specific objects, and pass it to our algorithm from our PhD guy, and we provide him some kind of simplified API to our database, so that he can take data from it that he needs. And that's all. That's how it works. We don't clean up our database. We just save data and let the PhD guy to decide what data he wants to use in his algorithm. Probably he will find out some algorithms that can be more efficient with using data that 2 months, 10 months, but he can think of some algorithms that do some correlation between the Wi-Fi that appear and disappear in time. So we store all data, we don't delete anything, but we scale all the stuff, and most of the things that we scale is our usage. All this stuff is done in the way that we can fire up new instances on demand, like using Google application engine or something else. Yeah, it doesn't matter. And that's all. That's how it works.
We can also scale not only servers but also trucks, because we can use a pool of trucks, our employee, and we can install an application for phone which has a GPS plus Wi-Fi, and that applications will send to our server some information, and we can provide some benefits for that clients who provide us some information. And also, we can use client with GPS instead of sometimes instead of trucks.
So the judgment points, we can scale everything. We do some simple solutions that works on our server side, so we don't use any scheduler or something like that. And we use from beginning some optimal way to communicate with our mobile phone, so that we don't need to upgrade it. So binary protocols and optimization here, but not on our server. So thank you.
All right. So questions? Not that easy.
What kind of database do you have?
It doesn't matter actually, they do Zookeeper or Mongo.
What would you recommend?
Huh?
What would you recommend?
Oracle prefer.
Yeah. We will start from this Oracle.
Well, this would be a good answer. As you said before, we're not Oracle today.
We will start from this Oracle. Yeah. We will want to pay.
Relational or NoSQL?
No SQL. We don't need SQL. Yeah.
Okay. How does your data get off the truck onto the database?
They came to our application. People say, hey, we install on each station some software, and then when track comes, they connect some cable to the computer and say, hey, upload this data to server, and it then uploaded.
So that happens when the truck comes back to the home base?
Yeah.
Only?
Right. Only when here.
So suppose they upload data directly to database? Or
No, to our application.
And how does the application communicate with the server?
Using binary protocols, there are a few options, like where we can do this with Wi-Fi, we do it like with Wi-Fi, where we have 2G, we do it with 3G, where we don't have anything, we do SMS. But the main thing is that we use binary protocol.
Install anything on the GPS tracker, yeah?
We think we look what does this device have on it, and we use appreciate like the most efficient from what we have, but we must support many kind of protocols.
So did you consider how long would it take for this data transfer to be done from every truck? And then assuming you're going to have to do that manually for every truck, let's say that each transfer will take maybe 20 minutes to do,
Okay.
and then you have 100 trucks. So
Yeah, this application does is it downloads to local machine all the stuff from track, then track can go to next delivery, and this application like do this download.
But you need to connect every device manually, yeah? So you connect manually every device in every truck, like having the 1,000 of trucks.
Yeah, like if we can do it in some other way to gather all this big data, we do it in this way. But it should be fast, like it should take not much time.
Okay. And
Like just to download this network from one local machine to other local machine.
I guess all trucks already have like the model with which are tracking all the data regarding all activities of the truck.
That's right. All right, more questions?
And also, if the clients really want it, we can have some flash models that they like to remove old, put new, and then download it from
Yes, that's
old.
how it is.
Yeah. So is there some requirement? Those they want to be like really fast
just
as this?
exchange.
We do just exchanging the flash memory.
in what format will communicate scientists with your database or with what?
We design
What is the
special.
protocol how scientists works with the database input data?
Design the special stuff so the scientists don't need to know much about database. We just have special API for
He
him.
knows information about incoming request or how
Yeah, we give him this the data that we take from client, and we give him access to database.
and how does it look like this data that comes from client? What is the format or how it
It's,
looks like?
as I said, this is a set about Wi-Fi identifier, it's MAC address, and strength of signal.
Okay, and one more problem. What if your database grows? So every day you gather.
We just scale it.
We just buy new server.
I mean, you work every day. Every day you got like 10 gigabytes of data.
10
You
gigabytes
work
per day,
1
okay.
year, 2 years, 3 years.
Okay.
We
You got-
have expired.
No, we don't have any expiration. We save all data.
Okay, you save all data and how
Okay,
you gonna?
10 gigabytes per day. It will be few petabytes in several years.
Okay.
Okay, it's like 10 boxes per day. Okay.
Yeah, but why do you need that?
We have the restrictions for.
Well, I'll give you one consideration. Today, the scientist has a particular algorithm to process raw data. Well, tomorrow he may come up with something better. So I think actually raw data is something that we pay a lot of money to gather. So, and storage is getting cheaper. I wouldn't necessarily advocate for storing it online, but there may be something to be said for the value of that data, right? It does age because it gets stale.
The other aspect of it is it's something that the customer owns, really. They pay for gathering.
That's actually another consideration, right? Who owns the data in your system? We haven't touched on this. Quite often, like we deal with HR data, customer owns data, and some of those, in some locations, have requirements to store this data. Oh, God.
More than that, they want every single click anybody has done in the application recorded for various reasons.
We can confirm. No, neither confirm nor deny that we do. Okay, I think we're out of time for this presentation, so thank you very much. And now, last but not the least.
Collect our data from two ways. The first way is is we can collect, we can collect this data from online, is from direct connection through the GPS, and in the end of day or end of week, it depends of requirements of different customers, because as we know, in different countries is different useful using for our service, and that's why it's maybe this information is not required for different people. And the next very, I think, as my own opinion, of course, is interesting way is collect data from users directly. When a user is ask our service about data, he sends to us information about MAC address and strong of signal of this address. And when we have some kind of MAC address that we don't know and we can't find in our database from, for example, it's hard for me to explain in English.
Okay, explain in Russian, that's okay.
No, I want to practice my English. It's useful for me.
Portuguese gets special points.
And if we can get, for example, 4 or 5 points from some devices, and through these points we know and we can find in our database, and the other points is not known for us, but we know MAC address and strongest of these signals, we can add these points in our database, and we can get new information from location of these people. And this is online, real-time information.
So to get it straight, so you're getting data off of the trucks, and you're also getting data based on the requests you're getting through the...
Yes, because people, our world is very changeable, and Wi-Fi points is real-time information, and we can get this information directly from users. I think it's not expensive for us, and it's easily for users. It's really that they ask for us, I think. And,
Do you think you can sell that?
That's an added value.
That's pretty cool.
It's becoming cheaper and cheaper.
Yeah.
The next is that we decided to make a RESTful API interface. The user will ask for information through the REST, and we will get information through the REST tracks through this kind of protocol. We decided to store our information in NoSQL database. This decision was based on that NoSQL is scalable. They can answer on big a lot of questions in a separate piece of time. And if we want to store our service in cloud, we know that a lot of cloud services using NoSQL, and its very scalability, it don't have a lot of strict data, and as we thought about maintenance some kind, and we can use some kind of sharding, and our service have to be online 20 hours per day. And that's why when some kind of clusters in maintenance mode, we can answer for our user during this day. What else? We can use cloud services. We're not sure about private cloud because our service is not so secure, I think. It's very useful. And this information I think it can be used in public cloud or some kind of that. And all users can get access to our service in different devices, and it's really not better for us.
Uploading data.
What?
Uploading data from devices.
For this?
From gathering devices.
From the truck service, right?
Oh yes, we can upload.
About variants of uploading.
Yes, I talked about it. first, and this kind.
So you have live way of doing it over the 3G or?
It's optional, of course, because 3G, it's customer have to
So you
pay.
support basically 3G, USB I can see there, and Wi-Fi.
Yes.
Okay.
And of course, we can update our data directly from users, and have to update this data.
Okay, so if the device has both 3G or Wi-Fi and GPS model, why do it need to connect to this app?
With what? Sorry.
Okay, if the device has both 3G and the Wi-Fi model, why do it need to connect to the app? You told that you got 2 ways of receiving.
Yes.
Uploaded data from
I directly talking that once a day or once a week when tracking is want to send data to us, it can set from Wi-Fi. But it's really optional. You can choose which kind of through the what way you will send data. And if you want to use Wi-Fi, it's okay. It's useful.
No, I mean actually, you told that your client app has like 2 modes. You can like send the
Not
straight.
client, it's gathering.
It's gathering. It's all about gathering.
Yes, yes. It's
Oh,
about
because
gathering
I told actually that it's client app.
Client app, it's up to client really.
Okay, it's not
in
gathering.
which way to send queries for us. It's up to.
You don't use this data to like to
Yes,
fill the database.
you can send queries to my application from direct way. It's up to you how you will ask me for this data. You can actually, if you know IT and you know you have some REST client in your home workstation, you can open in browser and just type this query and get in JSON. I wish it would be JSON answer from our
Okay.
All right, a few more minutes left, so probably one more question.
Tell us about ways how we will save battery.
how we will save our data.
Battery.
Yeah, one of the requirements was to design something that is very conscious about the battery life. I think, right, you sold that.
It's work.
How we will, can you translate?
Как мы будем сохранить батарею
Клиенту, да.
Uh,
Какие принципы дизайна включены в наш общее
oh,
решение, которое
yes.
помогает нам?
We have a different way to send answer in the client, and I think he can mark this type in request. But if client have to save energy or he can't have directly stateful direct access, he can get answers through them just SMS. It's very easy to us to send not to answer through the REST or internet services, just answer to SMS, and client will be happy because he don't have to.
Yeah, but how does the client make your request?
I think it's if SDK, beautiful SDK from Indian people, I think it's not very hard for them to add some kind of param into URL, and it will become a response type. And response type will recognize what kind of response the client is access. And when through some kind of interface, you can just to put some checkbox, and you will receive answer through the SMS or through the different.
Yeah, but if I already have a connection open to the server, I mean, I'm already connected. I already consume the battery by connecting to, 3G.
Yes, after that you can switch off your internet access and get answers through the SMS, or just we will send answer to you, and we will not care, give you answer. Or
Yeah, but at the moment when I switch off the internet access, I can no longer upload my information about the access point that I am.
Yes, when you send the request to us, you have already information about points that
Okay.
around of you. You know, it's really not this is impossible to get query to us, not knowing about points around of you. If you send query to me, you have some kind of information. After that, you can switch off your internet connection and give a rest and wait to SMS from us.
All right, thank you very much. Now we switch to the more exciting part of this. We're going to vote for the winner. As I said, the prize is nothing more than respect and admiration of your viewers. Cherish it, because that's all you're going to get. So, just a reminder the way the voting works, everybody has one vote. We're going to trust everybody not to cheat. We also get to vote, but we'll vote at the end. And the team with the most votes on presentation, completion of the solution, the design, some of the ideas that they've taken into the consideration will be declared the winners. So, we'll start going one by one. Team 1. By the way, you can't vote for your own team, so you have to vote for one of them. Because otherwise we're going to have... so, who believes Team 1 should be the winners? 1, 2, 3... 5, 6, 7, 8, 9. Okay, so 9 votes. Yeah, by the way, Mark, can you do make sure the votes tally up at the end? No, 9. Those 9. Okay, Team 2. Okay.
It's from our
Okay, was there one hand? No?
No, okay.
Oh, wow, that's Team 3.
Team 3.
Team 3.
Team number 3. Who thinks team number 3 should have won? 1, 2, 3,
Guys.
4.
Wait.
Смелее.
1, 2, 3, 4. Okay, 4.
Alright.
So we're
So I don't think our votes can sway anything here.
up to 13. Are we?
How many people are in the room? 1, 2, 3, 4, 5, 6, 7.
Еще раз, пожалуйста.
No, it's okay. When you do me?
So, who do you vote for?
I don't think it matters who do what. Let's.
I think we should.
Okay, but I'll cast my vote as I talk about what I like and what I found interesting in this presentation, and I think we'll talk a bit about what you guys found interesting about this process. For me, it's actually Team 1 for one reason. I'll talk a bit about it in the wrap-up. I like the way the team started thinking about the solution. Somebody listened, right, when I said, hey guys, we want 3 categories to be described. High-level components and entities. And as a customer, as a stakeholder, as a product manager, I asked those questions for a reason, so please listen to me, right? And I actually liked that the team managed not to get too much into the weeds. One of the lessons I learned as I design multiple systems, even though they don't call me an architect anymore, I still a wannabe, is start high level, right? There are times and places where you want to design bottom up. But quite often, if you're designing from scratch, you probably want to design top down. We'll talk a bit more about that. So that's what I like. I actually like what Team 3 did. They were the only ones who gave the answer of, hey guys, not only we can gather the data from the raw data from the trucks, right? But we can get the data from the clients and improve our data set, right? Because the problem with the trucks and access points do move. I think everybody figured out that the routers can move throughout the city. I love the fact that they figured out how to improve the user experience through the normal operation of the system. I think it's a pretty cool solution.
I tend to agree with everything that Leonid has said, and if I was to vote as a techie, which I truly am, I'd also go for solution number 1. However, as a salesman, I need to go for this one because this is an added value. This is something that can differentiate the system from all the other systems that the competitors are selling. Because no matter, for sales, no matter how well this works underneath, how beautifully designed it is, you're only providing one way of doing the same thing, that thing, right? Whereas the competition can come up with something else, and the sales process, that's where we get killed. So, my techie soul goes for this solution, but my sales goes for this solution.
Pablo?
Yeah, no, I think I would be repeating some of what you guys said. I really like the ability of having that time real data for the locations that is available. You know, so the truck went in through there. 2 minutes later, I'm in that location. I have that data available right now. That's pretty cool. I know that will not be available everywhere, but you know, that's really the most modern solution. But I think in terms of the presentation, the completeness here, I was still vote for number one. And I think number one can still kind of grow into that, into providing these extra services. But yeah, both of them were pretty good.
And one other thing that they've done here, which is also very nice, is this, right?
Yeah.
So they're the only solution that does not have to bring the truck back to download the data, if I understand correctly.
But it has costs, right?
Which was outlined, and you know.
But we have a sales guy.
Market. So I can say, do you want the cheaper solution?
Oh, the fancy one.
The fancy one that nobody else has.
Yeah,
right
we
now.
can proposal to our customer. And
No,
they can
I
decide.
really like it, and you were conscious about the fact that yeah, it's gonna cost more money, but you know, this is an option. You can switch it on and off.
Profit.
Yeah, one of the things I actually haven't talked about, and I want to touch on what Martin is, I was desperately looking for the name of the book so I can quickly on the fly add it to the slides. There's a book by Martin Fowler called Software Design from the Edison Westler Signature Series. And one of the things they talk about the book, and I remember reading it early on, we as a techies quite often think about what he defines as architecture when we design our system, right? The technical architectures of the system, and we all like to geek out on that. But something to be said, if you want to be an architect of a large system, right, about designing a architecture of the system, right? Because ultimately, not all of us are fortunate enough to work in systems. Like consumer stuff, it's probably a rest of it. But if you work in enterprise software, and architecture of the system, how you position and market it is extremely important. And I would agree with Martin, there's some interesting architectural advantages to the system over there, and you have to balance them, right? There is a balance between the architecture and the architecture, because obviously you still have to deliver the product, but positioning it against your competitors and being successful is important, because at the end of the day, nobody buys the software that the three of us built. No GB9 for him, no food for me, no flying around the world for Pablo. Okay with it. All right, let's spend 5 minutes. I'm curious to hear from all of you. What did you find difficult, and what did you find easy about working in a group of people, hopefully that you haven't worked with before, on the sets of requirements that are very, very high level and very light, and kind of, maybe if anybody wants to speak, what lessons have you learned from today? Again, there have to be volunteers, otherwise I'll start naming names and pointing fingers. English or Russian, if it's more comfortable in Russian, do it in Russian. He understands, I'll translate for you later. So, anybody?
As usual, most difficult part was understanding the customer, what customer wants. So.
That's right. Okay.
For me, the main problem was that the team we were working was situated everybody himself as architecture.
Okay.
And there was a problem when people to people were starting to talk about different parts of the system at the same time, because they thought this is the main problem for now. And we spent a lot of time to communicate about things which we could do one by one, but we were trying to talk about them in parallel.
Pablo, do you want to talk a bit about that? Because you probably face this type of situation every day in the day-to-day life, right? We have a lot of senior guys who are techies, and sometimes somebody has to come in and reconcile those differences and kind of guide the team.
Yeah, I think it's kind of understanding, having an agreement of what is really the priority in terms of where's the rubber meets the road in terms of what is most important. I mean, I think a lot of people bring different important things into the mix, but then it's kind of sorting it out and say, okay, what are the things that we can postpone in terms of the decision, you know, and then I agree that they're important but can be postponed. What are the things that are the things that the must-haves and the nice-to-haves and the, you know, those type of things. Kind of creating that understanding and then just prioritizing things, I think kind of goes a long way. So kind of start from the main blocks and kind of start kind of going down in layers until we have enough details to kind of present something back.
All right. Any other learnings?
Maybe a good presentation should be details and
That's actually very important, yeah, because you may have a great idea, if you don't sell it right, it's just gonna be.
If you're not able to deliver it right, and there are a lot of interesting books on the subject, and you know, even technical presentations probably have to live by the same rules that literature does. There has to be a beginning, the middle, and the end in the story, right? There's a lovely book if you're willing to tackle it in English, especially as you start talking to non-technical people, called Made to Stick. Right? It's about really how to take your ideas and communicate them in a sticky fashion, right? Because certain things stick in our minds. There are certain sayings or certain examples. It also talks about things like, actually one of my favorite sticky things from that book is this concept, which we fail quite often as engineers, is the concept of the curse of knowledge. It's very difficult to present on a subject that you know extremely deeply because it's very easy to forget what your audience doesn't know, right? So you're cursed with the knowledge, and you have to consciously think about it when you present the design of the system, because you may gloss on a point or forget a point that is extremely important for somebody in the audience to understand.
And another aspect of that, talking to the audience, you have to be aware of who you're talking to. Because if you're talking to a highly technical audience, you can assume certain things. If you're talking to a sales guy, you know, you gotta give it to me differently, right? I don't know what a Mongo is. I may know what NoSQL is, right? Like this kind of subtle differences in presentation.
You know what the dollar sign
Computer
is,
too.
I know what a dollar sign is,
Try to-
but if you tell me this is gonna take 20% less of bandwidth and you start going into kilobytes, I'll just go,
Just try to switch to computer.
what idea we're talking about, right? And I may ask, but I may not. I may just, you know, discard your solution because of that.
What if there's an audience which contains both like six people and so technical, you display it both ways.
Like right now, you know, it was hard to us to understand what we have to do. We have to say, our
If you have
products to you.
if you have a split audience that you're presenting to, most likely you're coming as a split group presenting as well, right? So there's going to be a new group of presenters. There's probably going to be a sales guy, there's going to be a techie, and there's going to be maybe someone else marketing something, right? And their role would be to guide the conversation in such a way that when there's a technical question, it's answered on a technical level. But in general, you do kind of have to go for the common denominator initially, and then you can drill it. Anything you want to say on that?
No. I think
That's
it's
how I would approach
important to know your audience, right? That's the key here. What else? All right.
What do you do with the roles when you, for example, you have this problem? You have a team of 4 people and everyone is an architect. How do you solve it? That's not how it's
Typical.
not everyone is an architect. For example, everyone is a techie guy, as you say, and everyone wants to make decisions which you know affect the solution goal.
So here's how I approach this, and Pablo has probably a different perspective because he plays a different role in our organization, right? As an executive, my role is to set up a team structure to ensure I have clear sense of responsibility. In project management, there's this thing called RASI chart. Responsibility, accountability, who needs to be informed about the decision, right? Having that clear for the team is extremely important because if you ever read, there's another book that I love called Anti-Patterns, the orange book, right? The design anti-patterns. And one of the anti-patterns in that book is design by committee. Design by committee does not work. It sucks, but somebody has to have the final say. Whether it's right or not, somebody has to have this unified 30,000 foot or 10,000 meters view of the system and say, hey, you know what? I am the architect, and ultimately, if there's a tiebreaker, that's the person that has to be the tie. And therefore, when we put design teams together, we try to make sure it's an odd number. Right? The other thing is arguments are important. I used to work in Toronto. Martin saw that. We would work with a bunch of other guys who were Russian Israelis, much like me. We would block ourselves in the room, and the VP of HR would run and say, hey guys, is everything okay? I'm like, yeah, no, just designing the system. Because from outside sounds like people have to kill each other. Right? One thing I've learned is heated arguments tend to lead to better designs. Because we would have a heated argument, we would go home, sleep on it overnight, and probably recognize each other's point. Anything else from your side?
No,
You probably face those decisions more often than I do at this stage.
Yeah, I think for this situation here, I think the voting strategy will probably be the best bet, just because everyone's kind of pulled together to try to say the same problem. So, but other than that, I mean, we need to kind of define the roles for each one, you know, and kind of try to differentiate a little bit. So kind of let someone maybe lead the communication strategy, someone lead the storage strategy, someone lead, and then kind of just really define, make calls and kind of advocate towards your selection, and then let others comment, and then kind of agreeing the interaction methods between each one of these components.
I would say one important thing to say is, especially when you're designing as a group, arguments are good. Arguments are healthy. Arguments typically tend to create better solutions. But everybody on the team has to accept that once the argument is done and decision has been made, everybody has to accept the decision, not dwell on the past and move on, right?
There's no going behind the back.
There's no going behind it. It's pointless to bring the past up and say, well, remember guys, I told you so? Doesn't matter.
Yeah.
We as a group have decided that's the right choice based on the data we had at the time. You got to move on.
And if you can't decide, well, there's always someone who needs to make that call, right?
Yeah.
Somebody's ass on the line ultimately. So there is always a person in that group who's more senior or responsible,
and ultimately, really,
sometimes that person
the higher you go in the organization, the only thing that changes is the amount of risk the organization is comfortable with you taking, right? There are decisions that I have to make that probably every once in a while override what Pablo and the team recommend, but ultimately we are a business. We are a for-profit publicly traded company. Shareholders expect certain things, and sometimes we have to make decisions we don't like. It is what it is.
But it's important for you guys to understand, because I was really, really upset a few times in my career because I had this beautiful solution design, and my VP, not him, or some would basically
Should I step
say,
out of the room?
You don't need to that. You know, since I don't work for you anymore, I can say whatever.
There is that.
There is that. And you know, I'd be pissed off because you know we went for some half-baked, stupid solution that yeah we can do it faster, but really our elegant design didn't get implemented. Well, there was good reasons always for it. Nobody makes those decisions just to make them to spite you, right? So as engineers, we feel kind of.
You have to assume that even those people that wear the nice expensive suits and used to be techies many years ago, they probably have the best interests in the company in mind quite often. Not always. So, as we wrap up, I have a question for you. Who here believes who here today has a role of an architect of some kind? Except for that guy. One, okay. Two.
All of you. Everyone, I guess.
All right. Formally, like in an organization, designated. Who believes as they progress to their career they want to become one? Okay, so you came to the right workshop, thank God. You know, I remember when I saw this movie, and Pablo, I finally found a way to stick the slide in this. Right? You know, it doesn't get any better, right? This young Neo, the architect in the room. Right? This is what I always wanted to become, and eventually I did, and then I got bored with that too, and I moved on. I want to talk about some things I've learned as I was progressing through my career. I've learned to design systems like that. Figure out what your continents are first. Then maybe zoom in on a particular continent and try to figure out what is that you need to do in that box, right? The top-down design. And only then get into the weeds and look at the city design, right? It's extremely important to start isolating the components together, and apart. And quite often we as takers like to think about the final solution, you know, Mongo, it's going to be nice, we can scale it on Amazon EC2 with Chef and Puppet, and we may use Vagrant to do the desktop stuff. Resist the urge, right? Start with the high-level stuff early on. The other thing I said, even though I lived in the States for many, well, not in the States for many years, 9 years, 8 years in the States and North America. Quite often we as techies engage in what I define, and ladies pardon my French, as what I consider engineering masturbation. Complexity for the sake of complexity, right? And the best example I can think of, and it's not my example, I stole it from somebody, is two space systems that two different countries have designed. There's this beautiful, beautiful system, right? Extremely complex, extremely expensive to operate. And then there's this. And by the way, there's only one still flying. And it has nothing to do with where I grew up, Pablo. Right? There's something to be said for architectural simplicity, because system fails. Complex system fail, they're extremely tough to maintain. Keep it simple. God knows how many times we have the conversations in-house about, hey, do we truly need that complexity?
Another fantastic space-related example of that is, you know, the Americans have spent $1 million designing a pen.
Oh, the pencil story. Yes.
To send to, you know, to space, and Russians just grabbed.
Does everybody know the pencil joke?
Right?
Okay, so US realized that zero gravity pens don't work, right? You can't write because the ink doesn't flow, so they designed this pen that writes upside down, under the water, and of course the Russians use the pencil. It's kind of funny, but it's important. I've seen so many software designs that I like that pen where the pencil would do just fine. As you guys said, and you figured it out, and we intentionally didn't make it easy for you, designing requirements, gathering requirements, it's tough, right? You know, last week, as I told you, I was on the phone with a customer together with the sales team, trying to understand what is that they're trying to protect using encryption at rest. And the story I heard from the sales guy was probably like that, or actually like that, which we couldn't build for any amount of reasonable money or maintain, and really what the customer wants more like that, right? Gathering requirements is tough, and there are techniques to do that, and actually books written on the subject, and I'll show you my favorite one. Communication, especially when it comes to communicating your designs. This doesn't work. Again, I give tremendous credit for Team 1. This was extremely well laid out, right? This is the type of stuff you want to use. It has to be simple enough that the person who doesn't have the curse of knowledge of what you've designed can figure out what is that you're trying to convey. Sometimes, build up the complexity. You can have it and target complex, but start simple, and then layer the complexity as you present the system. Get organized like that. And then one of the most important things that I've seen in system fails on is lack of common vocabulary, right? What's the client? What do we call a client, right? Early on, what I've seen successful teams do very effectively, early on identify all the terms of the system, defining them well, and actually playing the vocabulary policeman, and I do that at work as my guys know, right? When you say blah, what do you mean? Do you really mean that thing that runs on the truck or on the guy? Who's the client here, right? Ambiguity is what tends to get us in trouble. So defining clear vocabulary that everybody, not just the techie team, but the product management team can use, and then the sales team can use, will be extremely helpful. Because confusion is typically what creates this. This, in my mind, as you can see, was designed using very clear vocabulary. One of my favorite books on the subject, and I was fortunate enough to discover it early in my career, and I read, it's called Domain-Driven Design. Right? How do you go methodically about designing software on requirements? It talks about interviewing stakeholders.
Sorry.
5 cents. US, no, you can forward. Right, written by Eric Evans, forward by Martin Fowler, and then after that book I would consider reading the other book by Martin Fowler from his signature series about software design. It talks about higher level stuff when it comes to designing complex system, architecture, architecture, licensing stuff, all the non-technical things that we need to consider as we design systems. I think with that, we're going to put the corporate logo on the slide and say thank you very much for coming. Hopefully you enjoyed this. Hopefully you learned something today. Thanks, guys.